All right, well, welcome to today's lesson. This is a new topic, and we're moving away from general equations to equation of a line and slope today. Generally speaking, this is a new lesson, but it is also something that was probably covered in your grade 9 math course, as that's where equation of the line is generally introduced. But I'm going to repeat most of the stuff that you would do in grade 9 because, well, it's good practice to do that as a teacher. So um, what I'm going to do is start with getting my pen activated here and say to you, look at all equations of a line have an equal sign. Okay, so you'll see this consistently coming. There's an equal sign. And they have either both or an x or a y variable, one of the other. They either both or one, or at least one of them. And most equations have both an x and a y, but there are some special equations that don't. So I'm going to explain that today at the end of the lesson when you don't have both an x and a y. Most of the time you have both x and a y. All right, so they come in different forms. And the first form that we generally see is what's like standard form. This is like the formal form, like dressing up in your nicest wear. And this is what they look like. It will almost always have an x term, and the x term comes first. So this is what we call our x term. Oops. For some reason it likes to jump up on me here. X term. I'm just going to erase that x that was accidentally jumped up. Okay. And we also have a y term. Okay. And I'll grab the sign. The sign that goes with the y term generally belongs here. So y term. If there was a sign out in front of the x here, it would go with it too, but there's no sign, so we assume it's positive. And then we have the constant term, right? This is our number over here, and we just refer to it like as a constant. Okay. And it's out there on that side. And like I said, this is just your formal way of writing an equation. It's not really that useful, kind of like, when we dress up and we get into our fanciest outfits, they're not really that useful to us as far as, we're not going to do a lot of work in them. We're going to worry about spilling things on them. Well, it's the same thing. These things look nice, but they don't really provide us with a lot of information. And so mathematicians quickly realized that one of the ways we can deal with equations much better is to put it into what's known as slope-intercept form. And I'm going to show you a slope-intercept form here and tell you some very specific details about it. So first of all, the y term is always on the left, okay? Y on the left, okay? And it is always by itself. There is no number in front of it, never. We always get rid of the number in front of it by dividing everything by that number in front of the y just to get rid of it. We'll show you some examples if we're converting from a standard form to this slope-intercept form. So the other thing is the next numbers are always going to be then on this side of the equation, on the right side of the equation. And one of the first ones is the number that we'll find in front of the x. And this here is known as the slope. And if you recall from last year, we used a letter to represent the slope, and that was the letter m. Okay. And then finally, we have the number at the very end, which is your constant again. And this particular number is referred to as the y-intercept. So you can see how this equation format gives us a lot more information. And we give a letter to this one too. We call it b. I don't know why, but they just came up with these two letters. M, I think, was selected because S looked too much like a 5. And they didn't want to confuse with the value of a Y, and they wanted one letter, so they just chose the letter B. Sometimes you see these equations written like this, saying Y equals MX plus B, which is like, a format for representing this style. And so anything that exists in front of the x represents the m, which is a slope. Anything that's behind the x here is considered b, which is the y-intercept. Okay. And one further thing is that slope always equals the rise over the run. So when we talk about slope later, when we graph, you're going to see slope is like, the direction the line goes like this, right? Or like that, and that represents the slope. This could be another slope, okay? Steeper, less steep slopes are demonstrated by rise over run. And hopefully you did a little bit of work last year and you can recall that they talked about rise over run and slope. But what I want you to be able to do in this lesson is just extract the information, the data from the equation. So what I'm going to say is that we want to look at this and say, what is the y-intercept? Okay, so we just did this one, the y-intercept, which is listed right here. And unfortunately now my my pen doesn't work as well inside a table. So I'm just going to go back to the using my keyboard here. Just highlight this stuff out and center it so it's in the middle of the boxes. Okay. And my y-intercept here is going to be -4. And -4 can also be written, it could also be written as a point, because essentially what it is, y-intercept is where it crosses the y-axis, and that's a point, and that's 0, comma, -4. I don't care whether you write the answer as just -4 or you write it as this format. I generally give the answers in this format here as opposed to just -4, but it really doesn't matter to me. Okay, my slope, and I need to write this in a format that's going to look half decent, so I'm going to insert. Doesn't like me doing this very fast. It's not very fast, but it does work. Would be the number value in front of there we go. I'm just sort of getting to this point where I can write it in as an equation, and it's very slow here, so be patient with me. Well, maybe I'll do it in an easier way. This may not work. Oh, it is going to work. The slope is going to be 3 over 2, and it's a little slow writing this in, where the rise is the number on the top, which is 2, and the run is the number on the bottom, 3. And if the slope is positive, that means the slope is going to, I'm just going to use my pen again. Use my pen again. That means the slope is going to go like this. It's going to go up to the right. And so we just say R here, up to the right. And oh, that didn't work because I'm still in pen mode. Apologize. Trying to get out of pen mode. I think I'm out of pen mode. R, there we go. Okay, so any slope that goes up to the right is positive that way. And so we can continue on and do these ones here. This one would be +2. Oops, I've got to get the plus sign. Where's the plus sign? +2, or it can be written as bracket 0, comma 2. And so that is a way of writing it in that sense. The slope here is simply the number in front of x, which is 3. And when we get ones that are a whole number, the rise is always 3 and the run is always 1. So it's like 3 over 1. And that's really quite simple. And again, it's a positive slope, so it's R. Okay. This one is a little trickier. I'm going to just do it like this. I'm going to go 5 and go back to home here. I have a way of doing this where I can make it look like a fraction. And I'm just using my super cases. So -5. Yeah, oh, that didn't work very well. -5 over 2 as an example, right? And that is essentially my uh, Y-intercept minus, oh, sorry, I apologize. What am I doing? That's the slope. Let's move that. That is the slope. I'll put the slope right here. The Y-intercept is 3, positive 3. And I can also write that, like I can write positive 3 as the answer here if I want to, right? I don't have to put the plus because it's assumed, or I can write it as the point, 0, comma 3, like that, okay? And then I have, that's just two different options. And my rise here is 5. My run is 2 because this is rise over run. And because it is up to the left, or negative, it is up to the left. So I put an L here. And if this is kind of confusing for you, just try to realize I'm just dissecting the information from these graphs. I'm not trying to make it difficult. I'm just trying to grab that information out of the graphs, okay? So y-intercept here is going to come from the -5. So I'm going to write -5, and I'm going to put a few spaces. The other way I could write it is 0, comma -5 and brackets, meaning that it is a point on the y-intercept. And when we graph them, this will start to make more sense to you, hopefully. And my slope is going to, in this case, be 1/3. So 1, and I'm just going to slash third. That's probably the easiest way for me to write that. That means my rise is 1 and my run is 3. And it is a positive slope, so I put R here. Okay, if you just think of these things here as the R means positive slope and the L means negative slope. So up to the left is going to be negative, up to the right is going to be positive. And that's basically, you can just take information from any equation in slope-intercept form and do that. And I gave you a little worksheet to work on that for today's lesson, okay? Now, if I give you an equation that is already, or is in standard form, we can use our skills from solving equations to do some work here. Hopefully my pen will work well in this particular case. So I'm going to turn my pen on. And I want to isolate the y. So the first thing I want to do is move the 2x to the other side. And so I'm going to put my equal sign here. I'm going to subtract 2x here, subtract 2x here. And what I end up with is minus 2x. Oh, what the heck happened there? Let's just try to get back down here. My apologies. Minus 2x here, plus 6, because that's a positive 6, so we have to write it as a plus 6. And we have 3y here. The minus 2x disappeared. But I want that y to be all by itself. In order to do that, I divide it by 3. That means each term here has to be divided by 3. Okay, 3 over 3 is 1. That leaves me with y equals minus 2 over 3x. And since they're not evenly divisible, since it's a division, I don't do the division. I just leave it as minus 2 over 3 plus 6 divided by 3 is 2. And so now I can identify my slope. I can say m equals minus 2 over 3, comma, b, which is my y-intercept, equals 2. And I can get that information, and that's going to be very useful when I want to graph that line, okay? Much easier to be able to grab that information and do it. I'll do another example over here. Same thing. I have a 3x on this side. I want to subtract the 3x, and this is really the same thing over here. Subtract 3x from this side. And now what I do is I get minus 9y equals minus 3x plus 18. And then I'm going to divide by minus 9, divide by minus 9, divide by minus 9. Every side, every term gets divided by minus 9 because that's the rules in solving equations. I'm allowed to do that as long as I do the same thing to both sides. And so this is y equals, this can be simplified. if you recognize 9 over 3 can be simplified to 1/3, and minus over minus makes it a positive. So this becomes 1/3 x, a little bit of a trickier question. And here I have a positive divided by a negative. That's a negative, and it's 2. And there's my equation. M equals 1 over 3, and B equals minus 2. And you'll see in our next lesson that this provides us with valuable information for graphing. Now there are some special equations, okay? So I'm just going to get move down a little bit here and show you them. They are really quite unique, and that is, oops, I scrolled down a little too far. Let me see if there we go, back up. Where we have just y equals 3. And the easiest way for me to sort of explain these is to say this is kind of like, I'm going to actually move this like this. Think of a grid, and because that's what we're really doing is drawing a grid and saying, well, first of all, I can label my x and y's on here. Let me just get my pen back on. My x, there's another. This is my y-axis. For some reason, when I go to draw these, this is my x. And I'm not sure. Hang on, let me just try to erase that. Give me a second here. Come on. There we go. And I think if I draw my grid points just a little bit off, it works, okay? Where is y equal 3 on this? And so y equals 3 on this is 1, 2, 3 right here. Y also equals 3 here, and y equals 3 here, 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 here. So essentially, what you have is a line that goes straight across here. That's what y equals 3 looks like. It's a horizontal line that goes like this. And how is x equals minus 2 going to look? Well, I go, where's x equal minus 2 along this line? It is here, and it equals minus 2 everywhere along this line. So this becomes x equals minus 2. So see if I can draw these lines. I'm going to draw them using the computer tool. You would probably just draw them using a ruler at home. Okay, so if I use my insert tool feature like this, I can draw y equals minus 3 by going kind of like this. And just like that. And sometimes I can even change the color to black so it looks a little more distinctive. And if I want to, I can label this now. I can go back and label that. I'm going to do the oh, my apologies. That's not, I'm out to lunch. My apologies. That was wrong. Let me just highlight that, delete it, get rid of it. Okay, y equals 3 is right here. What was I thinking? See, I make mistakes too. So here's my shapes again. Grab my tool. Y equals 3 is right here. So really, I'm going like this. I was kind of doing the x equals minus 2 one before. It is perfectly flat. It has no slope, and it looks like this. And I'm going to make it black. And I can label this with my pen, okay? And insert. I can say this here is y equals 3. Everywhere along that line is y has 3. We don't care what x equals. X can be anything because the equation just says y equals 3. And we can do the same thing for x equals minus 2, which is right here. And anywhere along that line, x equals minus 2. So just going to scroll down just a touch and see if I can get the whole graph in here. Okay, it won't let me quite. There we go. And I'm going to go back to my insert, grab my line feature, and I'm going to tell you that x equals minus 2 is right here. And I'm going like that, make it black, and I'll label this one too with my pen. a little slow when I'm running this video program. This is x equals minus 2. And all along that line, all along this line right here is x equals minus 2. Now these are special um, ones, so don't get too hung up on them. Once in a while they show up. For some reason, textbooks love to throw a little x equals or y equals question in just to kind of throw a little monkey into the wrench, but they're kind of special case scenarios. Hopefully this helps and you can go and do your assignment. Most of the assignment addresses dealing with these kind of questions here, a couple like this, but most of them are dealing with these kind of questions here where you're just grabbing the y-intercept, the slope, understanding what the rise and the run is, and whether it goes up to the left or up to the right. And then we'll expand on that by actually drawing some lessons or drawing some lines next lesson. All right, hopefully that's helpful, and we'll talk to you again soon.